Plastic, plastic, plastic. We've become so accustomed to plastic in our everyday lives for its convenience amongst many other purposes it fulfills. So much so that it has literally integrated itself into our society. Plastic waste can now be found even in our own bodies. Therefore, how many times have you seen these images in the media of whales engulfed in plastic or turtles stuck in sea rings? This is abhorrent and an issue that is truly prevalent in New Zealand. So these solutions up here are some you might likely recognise, but they all have one major flaw. While they contribute to reducing the amount of plastic, new plastic that we add to the environment, they do not do anything about the plastic that is already floating out there, the tonnes and tonnes. And as seen in the media, New Zealand is truly in trouble. Our dependence on other countries, for example, to take in our plastic waste has become really unsustainable. So this truly raises the question of what is the solution to our plastic problem? Mycoremediation. Mycoremediation is a form of bioremediation, which is a process of removing pollutants from the environment using naturally occurring organisms through the use of fungi. The potential of this technology to fix our plastic waste problem is sustainable and extraordinary. So there are 3 fungi species which would be effective in reducing New Zealand's plastic problem: Pistolotiopsis microspora, Aspergillus tubangensis, and Xylerion maritimum. So plastics are polymers. Polymers are long chains of molecules that have very strong intermolecular forces of attraction. Intermolecular here means between molecules. This means that plastics persist in the environment for extended periods of time, hundreds and even thousands of years, because they're very hard to break down. Let's take polyethylene, for example, a very common plastic found in plastic bottles and, yes, the infamous plastic bag. So these monomers, ethylene, in the manufacturing process, are added up and joined together in a long chain to produce polyethylene. So, what is the unique part about fungus which can fix our plastic problem? Mycelium. Mycelium is the vegetative part of a fungus and is made up of branched thread-like structures called hyphae. These hyphae are the secret to breaking down the plastic. So, mycelium can break down plastic in a simple 2-step process. Firstly, the hyphae secrete enzymes, which are chemicals that speed up reactions onto the pollutants, plastic, which then break down these plastics, the polymers, into smaller units called monomers. This essentially reverses the plastic manufacturing process back into biodegradable, non-toxic molecules. And then secondly, these monomers are then absorbed by the mycelium and are perfectly safe for human consumption. So, hang on. I'm sure there are a few of you in the audience who are thinking about the microplastics in our ocean that have become such a relevant issue. Microplastics are so small that they can even manage to bypass the extensive filtration systems in place to clean our water. This not only means that our drinking water is contaminated with microplastics, but they also end up in the food, for example, in fish that come onto our plates. Fortunately, one of the fungi species which I mentioned earlier, Xylerion maritimum, in a study conducted by the University of Aveiro, proved that it was able to effectively break down 77% of microplastics in just 7 days, further demonstrating the potency of fungi. Now, there are extensive benefits that that fungi and micromediation would be able to bring to our plastic problem. First of all, environmentally, fungi clearly have the potential to clean up our waterways and the environment overall. Cleaning up our environment would mean we would decrease the toxicity of our land and waterways and therefore improve the health of our environment. This consolidates with the New Zealand government's goal for a cleaner environment. There would also be an increased likelihood of marine life and other such organisms because there'd be less plastic in the environment and therefore less chance of organisms dying from plastic-related causes. And if you're still not convinced, the American Society for Microbiology journals published a study that proved Pestilothiopsis microspora, one of the fungi I mentioned earlier, in only 2 weeks cleared almost 100% of a plastic sample in anaerobic conditions, meaning it did not need oxygen. Okay, now moving on to the social benefits. There would be a decreased risk of obesity and cardiovascular diseases as we would be ingesting less microplastics, and this was proven in a study by Columbia University. And furthermore, what's also interesting is that these fungi would become a viable and plentiful food source as edible, non-toxic mushrooms. Essentially, we're turning our trash back into our food, which is an innovative and good use of our resources and is beneficial to New Zealand, considering that we are affected by poverty, and therefore there are lots of low socioeconomic areas who are struggling to have food. And lastly, the economic benefits. In New Zealand, we have faced the problems recently of other countries refusing to take in our plastic waste, and the value of plastic has decreased dramatically recently. So in response, the New Zealand government has said in press releases that we need to fund the improvement of recycling facilities. However, with microremediation, we would not need to do this. We would be able to save money but from having to recycle and export with this solution, because it would be far more financially effective in the long term despite the initial startup cost, as proven by a study by Marav Rukna University. So hence, in conclusion, I've illustrated the evident need for fungi to clean up our plastic waste problem through the process of microremediation. This method is simple and brings tangible benefits to New Zealand, as it does not deter the plastic industry, which in fact produces $2.6 billion of revenue each year and generates 9,000 jobs, but rather mitigates the negative effects that plastics have on us and the environment. Thank you.